see this as a string of terms added together? Do you see that? Okay, so what are you thinking? Oh boy, oh boy, oh boy. Are you thinking that? Okay, so guys, look at this. Add 1, your new exponent is 3. Divide by the new exponent, your first term. Did you get x cubed over 3? All right, next term. Okay, what exponent is actually here that you can't see? 1. So you're going to add 1. Your new exponent is 2. You're going to divide by 2. So I have plus 3 halves x squared. Do you see how easy this is? All right. When you have just a number, because pi is just a number, it's a lot easier to say the derivative of what gives you pi, in my opinion, pi x, right? So it's a lot easier just to say, I want negative pi, so put negative pi x here. If you want to do it the other way, then what you do is put x0 here, okay? And you'd say add 1 divided by 1, and you'd get negative pi over 1 x raised to the 1 power. But don't forget what, guys? Don't forget him. Don't forget Charlie. Nice. Okay, let's move to this problem here. Oh boy, oh boy. Do you see it? Oh boy, oh boy. Okay, so here we go. We're going to take the integral of 2 sine x and the integral of 7 secant squared. The integral of 2 sine x is, do you see the 2 pulls out? So what's the integral of sine x? Any idea? Negative cosine x. Guys, at this point, every time I give you a problem, it's only going to have an x. But starting today, it could be a 7x or x squared plus 1 or something like that. You're going to do something different. But when it's just an x, you can just carry it down to negative cosine x. That is equal to negative 2 cosine x. Are you guys good with that? Let's do the second term. What's the derivative of negative 7 secant squared x? Well, negative 7 you can pull out. Okay, what's the integral of secant squared, guys? Tangent x. So I'm going to carry that down here. Negative 7 tangent x. And don't forget him, guys. Don't forget Charlie. All right, we're good so far. All right, let's move down, guys. Let's look at this problem. So guys, remember, there is no quotient rule in integrals. I mean, there is, but you don't want it. You don't want to do it, okay? So our goal is to get away from quotient rule. So first of all, guys, those of you guys who are not showing your work, you're skipping steps, okay? And then you get confused. So show all of your work, guys. This is really x to the 1/2. What I get that students do wrong is they'll say this is equal to x to the 1/2 dx. Can you tell me what's wrong? It's the negative 1/2, okay? Because it's x to the 1/2 down here, okay? But if you ever change numerator to denominator or denominator to numerator, you need to change the sign, okay? Once you get this, you're going to add 1. What's my new exponent now? What's my new exponent? 1/2. So if I divide by 1/2, I'm really multiplying by 2. This will be 2. This will be 2x to the 1/2 plus Charlie. That's a great answer. Colton, can you put that away? But you need to know, because you'll have some multiple choice on your test, that this is the same as this. Are you comfortable with that? Okay, we're looking at 4 on your homework from last night, guys. The problem said solve the differential equation, guys. When it says solve, what are you trying to find? When it says solve the differential equation, what is your answer? Y. It's saying what is y, or what is f? F of x is the same as y. Okay, so knowing that that's what we're going to do, we have f double prime x equals x to the negative 3/2. We also have f prime of 4 is equal to 2, and f of 0 is equal to 0. All right, so guys, we have f double prime, and we want to f. Think about this. F prime, f double prime. Okay, if I move on this side, this is a derivative. But I have f double prime, and I want to get to f. So guess what I have to do? Antiderivative. And how many times? Twice. Okay, so let's do it. Oh, I didn't mean to do that. Okay, so let's take the antiderivative twice. All right, so what does that mean that we do? Okay, we're going to pull on this side and take the antiderivative. And what is the antiderivative of f double prime? F prime plus c, right? But I'm going to move the plus c to this right side. Okay, over here I'm going to add 1. That means add 2 over 2. Okay, what is negative 3/2 plus 2 over 2? Negative 1/2. But when you divide by negative 1/2, you're going to multiply by what? Negative 2. So this will be negative 2 x to the negative 1/2 plus Charlie. Okay, I found f prime. But guys, I need to find Charlie. So the only way to find Charlie is go look for an initial condition. There's my initial condition. This says anytime the x is 4, the f prime is going to be 2. So you go plug this in. 2 equals negative 2. Actually, you can't plug into this x raised to negative 1/2. So let me change it. Guys, make sure you understand. Do you understand that this x to negative 1/2 is really x to the 1/2 on the bottom? Do you guys understand that? Okay, then that is really square root of x. All right, so now let me plug in 2 for the f prime, 4 for the square root. But guys, what's the square root of 4? 2. So this is 2 equals a negative 1 plus c. So what's your c equal to? Is it 3? Okay, so if it's 3, you're going to come up here, and this is 3. Is everybody good with that? So now I've got this new problem, and the new problem is f prime of x is equal to negative 2, x to the negative 1/2 plus 3. Now I want to go to f. If I have f prime, what do I have to do to get to f? Take the antiderivative there, take the antiderivative here. On this side, there's two terms here. So, oh boy, okay? So this is going to be, Colin, can you put that, Colton, can you put that away? So you're going to add 1. What's negative 1/2 plus 2 over 2? 1/2. Okay, Ryan, are you with us? It doesn't hurt to review, Ryan. So negative 1/2 plus 2 over 2 is 1/2. If you divide by 1/2, what are you really doing? Multiplying by 2. So I'm going to multiply this times 2. What's negative 2 times 2? Negative 4 x to the 1/2 plus, what's the integral of 3? 3x, and don't forget Charlie, okay? Now I have to find Charlie. Guys, I am done. Like, this is f, okay? But you have to put in what Charlie is. So you have to go back, find another initial condition. And this says every time x is 0, okay, that f is going to be 0. So what do I get for c here? 0. So this is 0. So my answer is f of x is equal to negative 4 square root of x plus 3x. Okay, do you guys see how to do that? What other questions do you have? Online, do you guys have questions? Myra, you're good? Number 13, okay. Let's look at 13. We're looking at 13 on the homework. So this is the integral of 5 cosine squared x dx. All right. Are you guys good that 5 is a scalar? Okay, so let's pull it out. So 5 integral of 1 cosine squared x dx. All right. So all I need to do is figure out this integral right here. Go look at my formula sheet. Actually, you should have them all memorized. Okay, but if you need to, now look at your formula sheet. Which one is 1 over cosine squared x? Oh, I'm doing the wrong one. Do you guys need this one? Oh, this is number 8. It is number 8. Does anybody need this one though? You guys are good? Okay. It's a, oh, I forget it. It's secant squared, by the way. But let's do number, you said what number? Oh, I see. I just looked at the left of 14. I can see why I did that. Okay, let's start all over. Sorry, guys. I'll look at 13. This is the integral of 2, 3 square root of x dx. All right. What's the scalar on this one? 2, not just 2, but 2/3. Guys, it's a lot easier if you can pull out that whole scalar. Okay. Do you see that this is a quotient rule problem? But we can't do quotient rule. So how do we get rid of that denominator? Yeah, bring this x to the 1/2 on the top. What does it become when you bring it to the top? Okay, do you guys see how you can pull that 2/3 out? Okay, so what you're going to do is you're going to add 1, divide by, what's negative 1/2 plus 2 over 2? 1/2, divide by 1/2 is really multiplying by 2. So guys, this is multiplying by 2 over 1 over here. So what you get is 4/3 x to the 1/2 plus Charlie, which is 4/3 square root of x plus Charlie. Okay, what other questions do you guys have? Number 10. Okay, number 10, okay, is the integral of 3 secant x tangent x dx. Okay, do you guys see the scalar you can pull out? You guys good pulling out that scalar? Guys, you can only pull out scalars, okay? You cannot pull out anything with an x. Make sure you understand that. If it has an x, you have to integrate it first, okay? Same with derivatives. You can't pull out anything with the derivative with an x. You got to integrate it first. All right, go look on your formula sheet. Is this on your formula sheet somewhere? Secant tangent. Yes, what is it? Secant x plus Charlie, and there's your answer. Okay, what other questions do you guys have? Notice, guys, today, up to this point, all these x's have just been x's, and that's why it's so easy to go with the trig functions. Tomorrow, we'll be putting 3x, 5x, x squared plus 1 in here, and it'll change your answer, okay? So be careful about that. What other questions do you guys have? You're good? Okay, online, guys, what questions do you guys have?
Not really.
No questions? Annie, you're good? Okay, we're good. All right, then let's move on. We're going to do u substitution. Guys, go into your calendar, mark this day. This is the day that you started u substitution, when all your problems went away. Ready? Okay. So if you look at this problem, now the hardest thing to figure out on these integral problems is what method do you use? Do you use the method that you used yesterday? Like we already know how to do it, or is it a u substitution problem? So let me show you. Do you see that this is two things multiplied together? So do you see its product rule? Okay, you want to get it out of product rule because you can't do product rule. So what you do is you'd say 2x times x squared plus 1 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 dx. And then you'd FOIL all of these. Does that make sense? And do you see what a big mess it would be to FOIL all these? So to avoid it, we do a method called u substitution. And what is u substitution? Well, first of all, what you do is you find your u. Okay, now what is your u? I'm just going to tell you, 95% of the time, it is what's in parentheses. Sometimes it's not, okay, but 95% of the time, maybe 90, but it's in whatever's in your parentheses. So if you do this and it doesn't work, you just try another expression. You find an expression set equal to u. And this is what we talked about. If we could get rid of this, it's going to get rid of our problems. Okay, so we're going to try to get rid of this. So what you do is you take the derivative of this. So you take the derivative with respect to x. Du dx equals 2x. Everybody with me so far? Then what I have is one fraction on the left and one fraction on the right.
Wait, so
you're going to take the derivative. Do you understand? I just took the derivative du dx, and the derivative of x squared is 2x, okay? Now, let me just give you guys a warning here. When I do this the first time, it's going to feel overwhelming. It's going to feel like there are 100 steps. But you have to realize it's the same 100 steps over and over. Okay, so it won't be so bad because I'm going to do the same thing over and over for every problem. Okay, first you find your u. Then you take the derivative of your u. Then you solve for dx. I have one fraction on the left. I have one fraction on the right. I have an equal sign in the middle. So I can cross multiply. After you cross multiply, your goal is to solve for dx. So I've solved for dx. Okay? Then this is called u substitution. You substitute two things. You substitute your u, so I've circled my u, and you substitute your dx. If you did not circle it, you keep it there, okay? So let me do the u substitution. This 2x I didn't circle, so I keep it there. This is my u, so I changed this to my u, so times u. This 4 I did not circle. This was not part of the circled, so I put u4. This dx I did circle. The dx is right down here. I copy what I solved for dx right here. Du over 2x. Okay, let me repeat what I did. First, I found my u. Okay, your u is usually what's in parentheses. It's what you want to get rid of. Then I took the derivative. Then I solved for dx. Then I substitute two things because this is called u substitution. You substitute your u and you substitute your dx. Everything else you don't replace. All right. Then you look at your problem and you say, can I get this to be all u's, no x's? Okay, because you don't want any x's. So then you say, do my x's cancel out? Do they cancel out, guys? You have to use real algebra. Is x divided by x equal to 1? Does it cancel out? Yes. As a matter of fact, the scalars cancel out too. This is 2 divided by 2. Guys, the scalars don't have to cancel out, but that's just a nice thing. So I'll say 2x divided by 2x cancels to 1, okay? Then my new problem is this, okay? First, I had only x's in my problem. Now I have only u's. No matter what you do, guys, you cannot have x's and u's. Everybody good with that? If you have x's and u's, you have to start all over and find another u or do something to your problem, okay? But now I've got a problem that I can actually do. This is a problem you could do last night. It's just it has u's instead of x's. So what do? You add 1 to the exponent. What's 4 plus 1? 5. You divide by the new exponent. So this answer is u to the 5th over 5 plus Charlie, and that is actually the answer to your problem. It's just the wrong answer, okay? It's actually a great answer. It's just the wrong answer because your problem had no u's to begin with. But what was my u? X squared plus 1. So what you do is in parentheses, you put in that u, x squared plus 1 over 5 raised to the 5 divided by 5 plus Charlie, and that is the right answer. If you take the derivative of this, you will see the derivative of this is your integrand right here. You can try it. It will work. Okay. Well, because, I mean, how else would you get it? I mean, because you need to get this answer. And so this is actually like the skeleton to get this answer. The denominator that's in your u answer, like this 5, you mean? I mean, all I'm doing is, this is my answer right here, but my u is x squared plus 1. So then you have to just replace that because you didn't have a u to begin with in your problem. You made that up. Does that make sense? Does that make sense? Okay, let's do another problem. Maybe it'll kind of wrap it up. We'll do a whole bunch, so. Okay, let's look at this problem. Okay, now I got to tell you, if you can use the methods that you used yesterday, that's what you want to do because that makes it a much easier problem. But if you want to use u substitution, you can also. Sometimes u substitution actually makes it harder. Okay, do you guys see the square root? That is really x cubed plus 1 raised to the what? 1/2. Okay, so this is my problem right here. Now, what you want to do is, do you see that this is a product rule problem, right? It's something with the x times something with the x. There is no product rule in integrams, okay, in integrals. And so what you want to do is say, okay, can I FOIL this somehow? Can I take this x cubed plus 1 and FOIL it somehow so that you just have 1x? And do you see, because of this 1/2, you cannot. Is everybody good with that? If it had been a 1, that would have been great. You could have FOILed this. Had it been a 2, right, you could have FOILed it, all right? But a 1/2, you can't. You're stuck. So what you do is you say, okay, I think this is a u substitution problem. Now, how do you do it? First, you find your u. So let me circle what I'm going to say is my u. It usually is the parentheses, okay? So I circle it, and then I take the derivative of with respect to dx on both sides, or with respect to x. So this is du dx. This is 3x squared. What's the derivative of 1? 0. Everybody good with that? So I have 3x squared. All right. Then you solve for dx. So this is going to be a fraction on the left, 1 fraction on the right, and equal sign in the middle. Cross multiply. I'll get 3x squared dx is equal to du. Solve for dx. dx equals du over 3x squared. All right. Yes. Are you? Oh, sorry. Okay. So guys, what I'm going to do is I always do the same thing. Find your u. Take the derivative of u. Solve for dx, then substitute 2 things. I'm going to circle what I substitute, my u and my dx. You always substitute 2 things. Guys, anything that I did not circle, okay, you do not copy down, okay? So I look at this and I copy down, I'm sorry, anything that I did not circle, I copy down. So I'm going to copy down the 3x squared. If I circled it, I'm going to replace it with either u or dx. This is my u, so I'm going to replace that with u. I still have a 1/2. This dx is right here, okay? So that's du over 3x squared. Okay, what did I do? I replaced 2 things, my u and my dx. If I didn't circle it, I copy it, okay? Then my goal here is to get everything in terms of u's. Okay, sometimes you don't have any x's here. That's great. But I do have x's here, but I have to ask myself the question, do my x's cancel out using real algebra? You have to use real algebra, yes. Because x squared divided by x squared is 1. Now the 3's actually cancel out too. Now again, I have to tell you, they didn't have to cancel out, but it's nice that they did. But I really just needed to get rid of the x's. If there were, like if this had been 3 and this had been 2, it would have been a scalar that was 3 halves. I would have just pulled out the 3 halves. Okay, so numbers don't matter, but the x's do matter. Okay, so let me rewrite this. This is the integral of u to the 1/2 du. What did I do? I started out with a really complicated problem, but look, this is really the problem that I have in terms of u. And then I do this problem like I did yesterday or last night. I add 1, the new exponent is 3 halves, so you divide by 3 halves. But dividing by 3 halves is the same as what, guys? Multiplying by 2/3. So this answer is 2/3 u to the 3 halves plus Charlie. And that is a great answer. It is the wrong answer. Okay, what do I need to do to make it the right answer? Yeah, plug in your u. So 2/3, my u is right here. Plug it in, put it in parentheses. X cubed plus 1, 3 halves plus Charlie. Okay, you got it? All right, and so this is the right answer. Okay. You ready for another one, guys? Mm-hmm. No, I'm good with just leaving it like that. Yeah, I'm good. But you do have some multiple choice on your test. So if it does, then you need to be able to recognize it. Okay. All right. So let's look at another problem. Okay. I have secant squared times this tangent x thing. And I'm looking at my formula sheet and I'm like, there's nothing like, there's a secant x times tangent x, but there's no secant squared times tangent x. Think about this. Let me distribute this and see if anything happens here. If I distribute this, secant squared x dx. Okay. Do you see if I distribute this, I'll be like, oh boy, oh boy. Do you see this? Because this one I could do. This is the integral of 3 secant squared x, which would be 3 tangent x. Everybody good with that? Over here, though, do I have anything on my formula sheet that's secant squared tangent? No, so I'm actually stuck with the same problem I had up here before. I don't know what secant squared x times something is, okay? Let's start all over. Let's make my u equal to the parentheses. Okay, and like I said, most of the time you use the parentheses, sometimes it's not, okay? But let's just try it. Okay, let's take the derivative of both sides. What's the derivative of tangent? What's the derivative of tangent? Secant squared x. What's the derivative of 3? 0. Okay, everybody good so far? Okay, I have one fraction on the left, one fraction on the right, cross multiply, and an equal sign in the middle, I can cross multiply. So what I get is secant squared x dx is equal to du. Solve for dx, I get dx is equal to du over secant squared x. Okay, I'm doing the same thing each time. First, you set your u equals. Then you take the derivative. Then you solve for dx. All right, what two things do I replace? My u and my dx. Circle them. Your u and your dx. If you didn't circle them, then all you're going to do is copy them down. So I have secant squared x still. Okay, u I circled, so I'm going to replace that with u. dx is right here, down here, so I'm going to replace this with du over secant squared x. Now remember, my goal is to get all u's here. Okay, so here's a question. Do all my x's cancel out? Using real algebra. Is secant squared x over secant squared x 1? Okay, that's good news. So I'm going to divide by secant squared x, divide by secant squared x, that's 1. So this is what I have left. Okay, I'm pretty happy with this. I started out with this complicated looking integral, and now this is the only integral I have. I actually need to integrate this, okay? What power is really here at the u? 1. So add 1. My new exponent is 2. Divide by 2. So do you see you get u squared over 2 plus Charlie? And that is your answer. It's just the wrong answer. It's a great answer, okay? It's just the wrong answer because you need to come back in, put in parentheses, put your u in parentheses, okay? Square it, divide it by 2 plus Charlie, and there There you have it. There is the right answer. And you can practice this. You could take the derivative of this and see if you get this back. Okay, I haven't done that, but hopefully you do. Okay, let's do another one. There we go. Do you see that this is product rule? Do you see it? Can you change this so it's not product rule? Yeah, isn't this really x times x squared plus 1 times x squared plus 1 dx, right? So you don't have to use u substitution here. You guys good with that? Okay, so if I wanted to, I could say, hey, this is really x times x4 plus 2x plus 1 if I'm foiling that right, because it's x squared plus x, oh, no, it's 2x squared. x4 plus 2x squared plus 1. Do you guys see that? I'm foiling that. And then I could distribute this. So that would be x to the 5th plus 2x squared plus x. That's the integral. Oh, sorry. Thank you for fixing that. Okay, 2x cubed plus x. And guys, is this a u substitution problem? No. Okay, so you need to recognize, hey, sometimes you don't have to use u substitution. But I want to also tell you, if you did use u substitution, you'd still get the right answer. Is everybody good with that? You might get a different answer, though, just a warning, because that plus c sometimes absorbs different constants. So you might get a different answer, but no worries. I can look at your paper and I can work down the problem, follow your work, and figure out if you did it right or not. Okay, here we go. Add 1 divided by 6. Add 1 divided by what now? 4. Okay, this x, there really is a 1 there. So I'm going to add 1, divide by what? Did you guys get the same thing I got? Okay, so again, be careful in your homework. I won't tell you which ones, but there are one or more, okay, where you don't have to use u substitution. And you can try it. The only thing with u substitution is when you don't have to use it, sometimes, not always, you get something kind of awkward. But it doesn't matter. I can follow your work and tell if it's a good answer or not. When you do integrals, it's not like derivatives. When you do integrals, you can get different answers from your friends. Okay, most of the time you won't. Most of the time it'll be the same. But you can get different answers from your friends. And so that's why, guys, if you're going to cheat on the test, I just want to let you know, I can tell if you did, because you'll do a method that, like, I didn't teach you, okay? And so you need to use my method, all right, to do u substitution. Okay, so guys, let's look at this problem right here. Do you see its product rule? You guys good with that? Okay, can you take this and multiply it 4 times? Do you want to do that? No. Go ahead, use u substitution. It's your turn. You can do it. Okay, find your u. It's usually what's in parentheses. Take the derivative of u. Solve for dx. Did you get dx equals du over 3x squared? Okay, you're going to substitute 2 things. Circle the two things you're going to substitute. Guys, if you're getting the answer wrong consistently, it's because you're falling apart on like your steps, okay? You're doing too many things at one time. Circle your u and your dx. Those are the two things you replace. Everything else you don't replace, all right? Then you ask yourself, I want to get this to be all u's, okay? So if I have x's, if I don't have x's, that's great. But if I have x's, do my x's cancel out using real algebra? Using real algebra, do they cancel out? Yes. So x squared divided by x squared is 1. So if I rewrite this problem, I have 2/3 u to the 4th du. It's still an integral problem. I haven't taken the integral yet. Okay, you can't drop that. All right, do you see the scalar, the 2/3? Pull the scalar out. So that's 2/3 integral of u to the 4th du. All right, do you see that this is a problem that I can do? I could have done this last night. So I'm going to add 1, divide by 5, okay? And so what I get is 2/3 times u to the 5 over 5 plus Charlie, okay? And students will get stuck here. Guys, this is just multiplying fractions. What's 2 times u to the 5th? 2u 5th. What's 3 times 5? 15 plus c, and that is your answer. It's a great answer. It's just the wrong answer. Okay, you need to go in and replace your u, because there was no u to begin with in your problem. And your u, sometimes u can be a multitude of things. It doesn't have to be what's in parentheses. Sometimes it works out when you set it equal to something else. So I need to see what your u is, okay? So put your u back in, and there is the final answer. Did you guys get it? Pat yourself on the back. Say, good job, dude. Okay? All right. If you really love yourself, give yourself a hug. Okay. Let's look at this problem. Okay. If you take a cube root of something, what is it really? What's the power really? You take a cube root, 1/3, all right? So let me rewrite this. This is the integral of x over the quantity 2x squared minus 1 raised to the 1/3 dx. Okay, guys, quotient, right? Quotient rule. Can't do quotient. What am I going to do? Can't do quotient. What am I going to do? Okay, use substitution, but you guys, okay, if I bring it up first. You actually don't have to, but it's actually a little bit easier if you bring it up first. Now, when you bring it up, you got to use real algebra, guys. You can't just bring it up. You got to change the sign on the exponent. Okay, next thing you need to observe, product rule. Do you see product rule? But what you have to do is FOIL this thing out. Can you FOIL anything that has a negative 1/3 exponent? No, you can only do it if it has a 1 or a 2. Maybe a 3, but that's a lot of work. So I would just do 1 or 2. Okay, now negative 1/3, you can't do it. So now you have to think about, what am I going to do? You're going to have to go use u substitution. Okay, how do you use substitution? Go find your parentheses, set it equal to u. Okay, again, it's not always the parentheses. And if whatever you set equal to u, if your x's don't cancel out, then just go back to the drawing board and pick another u. All right, du dx equals 4x plus 0. Everybody good with that? Solve for dx over here. This is divided by 1. So if I cross multiply, I get 4x dx equals du. So therefore, dx is going to be equal to du over 4x. All right? So what's my next step? Substitute two things. What two things do I substitute, guys? My u and my dx. Okay, I'm going to circle them. If I did not circle it, then I'm just going to copy it down. So this is the integral of x times u raised to negative 1/3. Your dx is du over 4x. Okay? I get students that just put random things in here. Guys, you're starting right here, okay? If you didn't circle it, it carries down. If you circled it, you replaced it. And don't put more things in it. Like you're working with this integral right here, okay? So guys, here's a question, because I want to work only in u's now. Do my x's cancel out? Do they? Using real algebra. Yes, so x divided by x is 1, okay? So I'm going to rewrite this problem. This is u to the negative 1/3 divided by 4 du. Do you guys see that the 4 is in the denominator? Is everybody good with that? You can't pull like denominators and numerators up and back and forth unless you change their exponents, okay? So the 4 is in the denominator. What's the scalar in this problem? What's the scalar? 1/4. So guys, you can pull out a 1/4 integral of u negative 1/3 du. Okay, then you're going to work this problem just like you did yesterday. You're going to add 1, which is adding 3/3. What's negative 1/3 plus 3/3? 2/3. But when you divide by 2/3, you're multiplying by 3/2. That's the hardest thing to keep track of all these. Okay, now you have 3/2, but see, you already had the 1/4. So you're going to have to multiply that together. So this is just fractions. 3 times 1 is 3. 2 times 4 is 8. And you're taking the integral, so this is u. What did we say this was? 2/3? Okay, u to the 2/3 plus Charlie, and that is a great answer. It is the wrong answer, okay? Make sure you come back, put in your u, and there is the right answer. And if you took the derivative of this, you're going to come back and get the integrand that you had to begin with. How are you guys feeling?